Hello everyone, thank you for signing in and watching my live stream. Welcome to SAT ACT Prep. I'm Mr. Matt and this is Dr. Tot. And today is stream 3 of 3 of operations with radicals. So we're going to look at the rules pertaining to adding, subtracting, multiplying, dividing, and ultimately solving equations, as well as rationalizing the denominator with radicals. All with radicals, or all with values containing radicals. Let me go ahead and share my screen with you. And as normal, this is a live stream, so the iPad does have a little bit of a delay, but I'll keep track of that in the broadcast corner. So the overarching rule here, remember that an easy way of remembering the operations or the rules pertaining to the operations of radicals is relating them to the operations of fractions. When we want to add or subtract fractions, we need a common denominator. Once we get a common denominator, we keep the denominator and add or subtract the numerators. With radicals, it's somewhat similar. We need common radicants in order to add or subtract radicals. So once we have a common radicant, we keep the radicant, add or subtract the coefficients. With multiplication and division, it's similar to multiplication of fractions, where we just go right across numerator times numerator, denominator times denominator with fractions. When we multiply or divide radicals, it's coefficient times coefficient, radicant times radicant, or coefficient divided by coefficient, radicant divided by radicant. The overall definitions here that we're working with, if we have some type of, let's say we have 2 root 3, so that's literally 2 times the square root of 3. If we have no index value, as there's nothing listed here, it's implicitly the square root. So where I'm writing in that kind of cranberry colored 2, that's called the index. And that determines which root you're taking. Are you taking the square root, the cube root, the quartic root, the fifth root, the sixth root, the 100th root? The square and the cubic root are the most common that you'll see. And again, just like when we write x, we really mean 1x, and technically we really mean 1x to the 1 power. It's just that all of those coefficients of 1 or exponents of 1 are inconsequential. They don't have any effect because 1 times anything is that same something. Something raised to the first power is that same something. It's just it by itself. So in mathematics, when we write x, we really know that all of these other characteristics are implied. It's the same thing with that index value of 2. Wherever you don't see the index value, then you're going to assume that it's the square root. So if there's if there is no little number on that radical sign, then you know it's implicitly 2. Also, just some definitions. So the 2 here would be called the coefficient. And the 3 would be called the radicant. And the sign, of course, is called the radical sign. If you have any questions, then feel free to let me know. You can post in the live chat feed, or you can drop a comment below. And in streams 1 and 2, we went through a significant amount of these additions and subtraction and multiplication and division problems, but I just want to refresh your memory quickly. I'm going to give you 4 minutes, and I'd like you to complete 1, 2. I'm going to label these as 1, 2, 3, and 4. After the 4 minutes is up, about 2 minutes in, I'm going to start to solve. Remember that you need common radicants in order to solve here, in order to add or subtract. So you can factorize the term. If you don't have common radicants, you can find the prime factorization of the terms. If it's the square root, as all of these guys here are the square root, then for every 2 prime factors underneath the radical, you can pull 1 outside. Hopefully, after you do a little simplification in that manner, you'd have common radicants, which then you'd be able to keep that value and add or subtract the coefficients directly. And again, in about 2 minutes in, I'll start to answer them, and then after the 4 minutes, I'll get you about halfway and give you about 2 minutes more to finish them. All right, so I'll keep track of the time in the upper right-hand corner and update it every minute. Okay, so let's look at these. Oops, I'm sorry. Oh no, what happened? Sorry, deleted that by accident. My bad. Okay, so let's look at these, and then I'm going to give you some more time. I started factorizing all the terms. And so afterwards, I'll give you some more time. If we break down the factors of 50 and 8, notice that 50 divides into 2 times 25. 25 breaks down into 5 times 5. So we could rewrite 50, or the first term, as 8 times 2 times 5 times 5 plus 5 times 2 times 2 times 2. Notice that for every pair underneath, we can bring 1 outside. So this is the same thing as 8 times 5 times the square root of 2. We're left with 1, 2 underneath the radical, plus 5 times 2 times the square root of 2. So then that would simplify into 40 root 2 plus 10 root 2. And so your answer here is going to be 50 root 2. Once you have common radicants, you keep the common radicants, add or subtract the coefficients. I'm going to give you 4 more minutes because I know these are a little bit longer problems, but I wanted to let you loose on on a few examples and let you think about it, and then give you an example to go off of. But I'll give you 4 more minutes. Let's look at 2, 3, and 4, and then we'll move on to multiplication. Okay, so looking at number 2, we have 3 times the square root of 45 minus 7 times the square root of 20. 45 breaks down into 5 times 45. 5 is prime. 5 times 9 is 45, 5 is prime, but 9 breaks down into 3 times 3. So we can rewrite that as 3 times the square root of 3 times 3 times 5. 20 breaks down into 5 times 4. 5 is prime, but 4 breaks down into 2 times 2. So we can rewrite 7 root 20 as 7 root 2 times 2 times 5. For every pair of factors underneath of the radical, we can bring one factor outside of it. So that's equivalent to 3 times 3 times the square root of 5 minus 7 times 2 times the square root of 5. 3 times 3 is 9, so we're going to have 9 root 5 minus 7 times 2 is 14, 14 root 5. 9 minus 14 root 5 is going to be a negative 5 root 5. Number 3, 4 root 98. 98 can break down into 2 times 49, and 49 breaks down into 7 times 7. The pair of 7s factor out, so we're going to end up with 4 times 7 times the square root of 2. 6 times the square root of 128. We can factor 128 into 7 2's. So that breaks down into 7 individual 2's. That leaves you with 3 pairs of 2's and 1 remaining 2 left underneath the radical. So 6 root 128 is the same thing as 6 times 2 times 2 times 2 times the square root of 2. That's right here. So 2 times 2 times 2, that's going to be 8. 8 times 6 is 48. So this is going to end up being, and 4 times 7 is 28. So we're going to have 28 root 2 plus 48 root 2. And that's going to be 76. So that's going to be 76 root 2. For number 4, we have 5 root 135 minus 2 root 60. We can factor 135 into 5 times 7, 5 times 27. 5 is prime, but 27 breaks down into 3 times 9. 3 is prime, but 9 breaks down into 3 times 3. So we can expand this into 5 times the square root of 3 times 3 times 3 times 5. One of those pairs of 3's will come out, and it will be 5 times 3 times the square root of 3 times 5. That's the first term. The second term, minus 2 root 60. 60 breaks down into 3 times 20. 20 breaks down into 4 times 5. 5 is prime, but 4 breaks down into 2 times 2. So 2 root 60 is the same thing as 2 times the square root of 2 times 2 times 3 times 5. That pair of 2's can come out, so we're going to be left with 2 times 2 times the square root of 3 times 5. This is going to give us 5 times 3 is 15. This is going to give us 15 root 15 minus 4 root 15. We have common radicants, so we just subtract the coefficients. 15 minus 4 is 11. So our answer to number 4 is going to be 11 root 15. If you have any questions, then please let me know. Now remember, relating the rules of radicals back to the rules of fractions. When we want to multiply, we just go numerator times numerator over denominator times denominator. Very similar to the rules with radicals. We go coefficient times coefficient, radicand times radicand. And the same with division. You just divide the coefficients by each other, making sure to get the order right. The first term will be the numerator, the second term will be the denominator, and you multiply that by the radicand divided by the other radicand. So I'll give you 4 minutes. At the 2-minute mark, I will start to solve. Okay, so looking at the first problem, 6 times the square root of 7 times 5 times the square root of 8, or 6 root 7 times 5 root 8. So we take coefficient times coefficient, so 6 times 5 is 30, radicand times radicand, 7 times 8 is 56. So we have 30 times the square root of 56, which actually we could simplify further. Notice that 56 breaks into 7 times 8, 8 breaks down into 4 times 2, and 4 breaks down into 2 times 2. So this is the same thing as 30 times the square root of 2 times 2 times 2 times 7. And we can pull one pair out. So that's the same thing as 30 times 2 times the square root of 2 times 7. So that's going to be 60 root 14 as a final answer to number 1. I'm sorry, Mark, I didn't see your comment before. Yes, it's really true. It is true that adding and subtracting seems a lot harder than multiplying and dividing, because multiplying and dividing just goes right into coefficient, radicand times radicand. You're absolutely true. And that's also going to be true when you get into calculus and you start looking at simplifying functions of functions. You'll see that because of the relationship, the scalar relationship that's implicit in multiplication, that the values have relationships to each other, and so getting rid of coefficients is actually a lot easier than getting rid of constants that are just gleamed on by addition or subtraction, because adding or subtracting finite values from each other don't have necessarily implicit relationships, where multiplication and division are scalar projections of one value out by another. So you see that that's a theme that'll start to develop in upper level mathematics. So number 1 was 60 root 14. Number 2, we have 48 root 12 divided by 8 root 3. So again, we just attack it coefficient divided by coefficient. So 48 divided by 8 is 6. 12 divided by 3 is 4. The square root of 4 actually evaluates into an integer because 4 is a perfect square. So the square root of 4 is 2, so this becomes 6 times 2, which is 12. The third one, we have 4 root 2 times 5 root 8. So again, 4 times 5 is going to be 20. 2 times 8, or root 2 times root 8, I should say, is going to be root 16. The square root of 16 does evaluate into 4 because 16 is a perfect square. So we end up with 20 times 4, which is 80. And lastly, we have 16 root 42 divided by 8 root 7. So 16 divided by 8 is going to give us a coefficient of 2. 42 divided by 7 is going to give us a radicand of 6. And 6 only has prime factors of 2 and 3, so there are no pairs of factors in the factorization of 6. So that's already in simplified form. So our final answer would be 2 root 6. If you have any questions, then please let me know. Now I want to talk about rationalizing the denominator. So oftentimes in SAT and ACT problems, they'll give you this problem to work out, and by the end of the algebra, you'll be left with a radical, some type of radical form, but it doesn't match any of the answer selections. And it could be the case that your form, or the answer that you simplified to, contains a radical in the denominator. And it's technically inappropriate in math to leave a radical in the denominator. They always want you to it's called rationalizing the denominator. And so you do that by multiplying by some fraction equivalent to 1, similar to how we convert from units from one unit to another. We're doing unit conversion. When we go from miles to feet, for example, we multiply by some version of number of feet that is equivalent to 1 mile. something divided by itself is 1. 1 times anything is that same something. So theoretically, when you multiply by values that are conceptually equal, that are listed as the numerator and denominator of a fraction, it all represents 1. And 1 times anything is that same something. So that's the same type of thing we're going to be doing here. I'm going to solve number 1 with you to give you some notes, and then you're going to look at 2 and 3 individually. So looking at 1, we have 4 root 3 minus 8 quantity divided by 12 root 2. I want to get rid of that root 2 in the denominator. So I'm going to multiply it by root 2, because if you multiply by the radical itself, that's equivalent to root 2 times root 2, or in other words, root 2 squared, because it's something times itself. And square rooting and exponentiating, or raising to a power of 2, are opposite operations. Just like multiplying by 2 and then dividing by 2 will cancel out, just like adding by 5 and then subtracting by 5 will cancel out or undo what you originally did. The same thing here. So if I multiply the denominator by the square root of 2, I have to make sure that I multiply the numerator by the square root of 2. Remember the overriding rule in mathematics. You can do practically anything that you like as long as you do the same thing to both or to all sides, depending on how many sides you have. Like an inequality can have more than 2 sides. But usually if you're talking about an equation, you have 2 sides. As long as you do the same thing to the left as you do to the right, as long as you do the same thing to the numerator as you do to the denominator, and vice versa, then you're all good. But here we want to get rid of that root 2, so I'm going to multiply by root 2 over root 2, which is an equivalent fraction to 1, which is not going to affect the value here. But I do need to make sure that I distribute to each value in the numerator and to the denominator. Where I only have one value in the denominator, which is pretty straightforward, but I need to make sure that that applies to both values in the numerator. So I'm going to have 4 root 3 times root 2. So that's going to be 4 root 6. Remember, just radicand times radicand, coefficient times coefficient. If there's nothing listed, then there's implicitly a coefficient of 1 there. So if that helps, you can write out 1 root 2, or instead of just root 2. So 4 root 3 times root 2 is going to give us 4 root 6. Negative 8 times root 2 is going to give us a negative 8 root 2. In the denominator, 12 root 2 times root 2 is going to give us a 12 root 2 squared. So that's going to be 4 root 6 minus 8 root 2 divided by root 2 squared is just 2. So that's 12 times 2. So that's going to turn into 4 root 6 minus 8 root 2, quantity divided by 24. Now notice that each of the values, each of the coefficients in the numerator and denominator, the 2 coefficients in the numerator and the 1 value in the denominator, are all divisible by 4. So I'm going to pull a 4 out. Because the values in the numerator are separated by subtraction, and this also applies to if they're separated by addition. But if they're separated by addition or subtraction, you have to consider them bound to each other, and they have to have the same factor or be divisible by the same factor if you want to simplify by that factor in the fraction. So I'm going to put 4 on the outside of a set of parentheses and then divide each term inside the parentheses by that value. 4 root 6 divided by 4 is just root 6. Negative 8 root 2 divided by 4 is negative 2 root 2. 24 divided by 4 is 6. So now you can see that the 4's will cancel directly, and my final answer here is going to be root 6 minus 2 root 2, quantity divided by 6. If there are any questions, then please let me know. I'll leave that there. Otherwise, I'm going to give you 5 minutes. I'd like you to look at questions 2 and 3, please. Okay, so looking at these guys, I'm just simplifying here a little bit. Number 2, we have 5 root 12 plus 6 quantity divided by 4 root 3. Excuse me. We're going to rationalize the denominator by multiplying by root 3 over root 3. And so we get 5 root 36 plus 6 root 3. Quantity divided by 4 times the square root of 3 squared. So that's going to turn into 5 times 6, which, because root 36 is 6. It evaluates into 6 because 36 is a perfect square. So we're going to end up with 5 times 6 plus 6 root 3 over 4 times 3. So that turns into 30 plus 6 root 3 quantity divided by 12. All of those coefficients are divisible by 6, so I can pull a 6 out of the numerator and denominator. So I end up with 6 times the quantity 5 plus root 3. Quantity divided by 6 times 2. The 6's cancel, and so the final answer to number 2 is 5 plus root 3, quantity divided by 2. For number 3, we have 8 root 30 minus 9, quantity divided by 5 root 6. So I'm going to multiply by root 6 over root 6. That's going to give me 8 root 180 minus 9 root 6, quantity divided by 5 times the square root of 6 squared. I can take 180 and factorize it, so that's going to break down into 3 times 60. 60 breaks down into 2 times 30. 30 breaks down into 3 times 10, and 10 breaks down into 2 times 5. So the square root of 180 is the same thing as the square root of 2 times 2 times 3 times 3 times 5. And so we have 2 pairs of 2's and 3's. Excuse me, we have a pair of 3's and we have a pair of 2's, I should say. So we can pull 1, 2 and 1, 3 outside. So that's going to turn into 8 times 2 times 3 times the square root of 5 minus 9 root 6, quantity divided by 30. Now, 8 times 2 times 3 is the same thing as 8 times 6, which is 48. So this is going to turn into 48 root 5 minus 9, quantity divided by 30. And it looks like all of those are divisible by 3. If we pull a 3 out, 48 divided by 3 is 16. So this is going to be 16 root 5 minus 3. 9 divided by 3 is 3. 30 divided by 3 is 10. So the 3's cancel now. And your final answer for number 3 in simplified form would be 16 root 5 minus 3, quantity divided by 10. If you have any questions, then please let me know. Also, feel free to let me know if there's any recommendations. If you guys still feel uncomfortable with any of these problems, I'm always open to recommendations for any extra videos. Also, I started to do SAT problems of the day on my social media, so please friend and follow me on Twitter, Facebook, and Instagram, and I'm posting pretty much every day problems that are related to the class. So Mark, why did we lose the root 6 at the end? Oh my goodness, thank you very much. No, that's absolutely right. I'm so sorry. I dropped the root 6. My apologies. Thank you very much, Mark. Good eye. So we have root 6 here. I'm sorry, guys. This 3 should have a root 6 attached to it. Thank you very much, Mark. Yep, that's totally my fault. Very good eye. Drop the root 6 at the end, and that's so easy to do. Okay, if there's any other questions, then please just let me know. Now, let's look at some equations. So, the rule here, to remove a radical sign, exponentiate by a value equal to the index value of the radical sign. For example, if the radical is taking the square root, then the index value is 2. So you raise both sides of the equation to a power of 2. If the radical is taking the cube root, then raise both sides to a power of 3. So I want you to solve the following equations for the missing variable and simplify completely. So the name of the game here, remember that if you have common radicants, you can add or subtract the whole radicals. So in both of these situations, the radicant is unknown, but they're both m. So you can add or subtract those entire values, 3m and negative 5m. They can combine together. You don't do anything to the radicant. You just add or subtract the coefficient. The same thing is true for number 2. They're both x. So they might not be a number, but they both represent the same value. So you can use the operations of radicals here. Oops, I'm trying to get my eraser. Okay, I'm going to give you 4 minutes, and then we'll go through these two problems. Okay, so for number 1, we have negative 18 plus 3 root m is equal to 6 minus 5 root m. So the 3 root m and the negative 5 root m both have common radicands of the variable m. So we may not know what the variable represents or the value that it stands for, but it does stand for the same value. So they do have common radicands. So I'm going to add 5 root m to both sides. Oops, excuse me. That's going to cancel 5 root m on the right-hand side and leave me with negative 18 plus 8 root m is equal to 6. Then I can add 18 on both sides, and that's going to cancel on the left and give me 8 root m is equal to 24. Dividing by 8 will cancel 8 on the left, and so I'll have the square root of m is equal to 24 divided by 8 is 3. And then I just square both sides in order to solve for m, because I don't want the square root of m, I want m. So m is equal to 3 squared, which is 9. So the answer to number 1, m is equal to 9. For number 2, I'm going to add 5 root x to both sides, and that will cancel the 5 root x on the right. So that's going to turn into 4 plus 4 root x. Remember that there's implicitly a 1 here in front of that negative sign. So negative 1 root x plus 5 root x is going to be a 4 root x. And that's still going to be set equal to 12. So now I can subtract away 4 on both sides. And I get 4 root x is equal to 8. If I divide by 4, just whittling away at what is keeping x from being by itself, 4 cancels on the left-hand side, and I get the square root of x is equal to 2. 8 divided by 4 is 2. So then finally squaring on both sides, because I don't want x, the square root of x, I want x. So x is equal to 2 squared, which is going to be 4. So the answer to number 1 is 9. And the answer to number 2 is 4. If you have any questions, then please let me know. Oh, Mark, yeah, so make sure that you follow the PEMDAS, right? So you want to make sure, what I do, PEMDAS can be a little bit confusing from time to time. What I do is I get all of my variables together, and then I ask myself, once the variable is on one side of the equation, what's the farthest thing away from that variable on that side? So going back to those equations, the m is wrapped together next closest to the 3, and the negative 18 is farthest away. Or the 4 is farther away than the negative 1 outside of the root x. So I just get rid of the things that are farthest and work my way towards the middle, towards that inside variable that they're asking for. So that's usually how I remember it. But PEMDAS is a good general rule, but there are exceptions to where PEMDAS can be a little bit confusing. But generally, I just try and work from the outside in. First, get all of your variables to one side, or collected together. All the variables that have the same variables to the same power you can collect together. And then try and work from the outside in to get the one variable that you want isolated by itself. Okay, I'm going to give you 4 minutes. Please look at questions 3 and 4. Okay, so for number 3, I added 5 root c to both sides, canceling on the right. And so that got me negative 10 plus 20 root c is equal to 10. Then adding 10 on both sides gives me 20 root c is equal to 20. Then I divide by 20 to get root c is equal to 1. And then square both sides, because you don't want root c, you want c. So c would be equal to 1. So 1 is the answer to number 3. Problem number 4, I added 7 root h to both sides. So I end up with 18 is equal to negative 9 plus 3 root h. Negative 4 root h plus 7 root h would be a positive 3 root h. Then I'm adding 9 to both sides, so that gives me 27 is equal to 3 root h, allowing me to divide by 3 on both sides, leaving root h is equal to 9. And then finally squaring to get h is equal to 81. If you have any questions, then please let me know. Otherwise, let's look at 5 and 6. Now 5 and 6 have cube roots. So instead of squaring to get rid of the radical, you're going to have to cube. You're going to have to take the third power. So I'm going to give you 4 minutes, and then I'll start solving after about 2 minutes, and then we'll go through the both problems in their entirety. Okay, so for number 5, 20 plus 6 cube root of f is equal to 50 plus 3 times the cube root of f. So I subtracted 3 cube root f on both sides. So I get 20 plus 3 cube root f is equal to 50. Then we can subtract 20 on both sides. So 3 cube root f is equal to 30. Dividing by 3, we get the third root of f is equal to 10. But I don't want the third root of f, I want just f. So now I have to cube both sides. The cubing of the cube root of f eliminates. Those are opposite operations, so we're just left with f. F is equal to 10 cubed. 10 cubed is 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So f is equal to 1,000. 6 as 20 plus 5 times the cube root of p is equal to 35 plus 2 times the cube root of p. So I can subtract 2 cube root p on both sides. That gives me 20 plus 3 cube root p is equal to 35. Subtracting 20 on both sides gives me 3 times the cube root of p is equal to 15. And then dividing by 3 on both sides, we get 3. The third root of p is equal to 5. Cubing both sides, we'd have p is equal to 125, which is 5 raised to the third power. 5 raised to the third power is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. If you have any questions, then please let me know. Otherwise, let's look at 7 and 8. I'll give you 4 minutes. Actually, you know what? I'm going to combine these because I'm going to give you a little bit of a challenge. I'm looking at the time, and we kind of have a little bit too long for just one set of problems, but then not long enough for two. So I'm going to give you a challenge. I'm going to give you 6 minutes. And I know the numbers are off here. I apologize. These come from the problems that we didn't get to in session 2. I'm going to give you these 4 problems, and I'm going to give you 6 minutes. After 2 minutes, I'll start solving. So at the end, we'll pretty much hopefully end right on time. But I'll give you 6 minutes. Please look at these 4 problems and disregard the question numbers. That's irrelevant. So just go ahead and solve for the missing variable listed in each equation. Okay, so number 8. We have 8 plus 24 times the quartic root of d, that's a fancy word for the fourth root, is equal to 24 plus 16 to the quartic root of d, or times the quartic root of d. So I'm going to subtract away 16 times the fourth root of d on both sides. That's going to give me 8 plus 8 times the fourth root of d is equal to 24. Subtracting 8, I'm right here, highlighting in blue. So subtracting 8 on both sides, then I'm going to get 8 times the fourth root of d is equal to 16. 24 minus 8 is 16. Dividing by 8, I get the fourth root of d is equal to 2. And then I just need to exponentiate both sides to the power of 4. 2 to the fourth power is 16. So the answer to 8 is 16. For 13, kind of jumped there, but that's from the problems. That's because these are problems from yesterday. But 13 here, notice that even though the radicand is super fancy, it's 2x minus 6, and it looks super complex, it's the same radicand on both sides. So you can still just add or subtract coefficients and keep the radicand. So I subtracted 5 times the cubic root of 2x minus 6 on both sides. That left me with 8 is equal to the cubic root of 2x minus 6 quantity plus 6. After subtracting 6 on both sides, that left me with 2 is equal to, that's right here, whoops, highlight in blue. So that left me with 2 is equal to the third root of 2x minus 6. To get rid of that cubic root, I'm just going to cube both sides. So that takes away the radical on the right, but on the left I get 2 to the third power, which is 8. So 8 is equal to 2x minus 6. Adding 6 to both sides, 8 plus 6 is 14. So 14 is equal to 2x, and then I divide by 2 to find x is equal to 7. Similarly with number 14, I have negative 3 times the quartic root of 6c plus 25 quantity minus 8 is equal to negative 4 times the quartic root of 6c plus 25 quantity minus 3. I'm going to add 4 times the quartic root of 6c plus 25 to both sides. That's going to cancel out on the right and become just 1 times the quartic root of 6c plus 25 on the left. Minus 8 is equal to negative 3. So I add 8 to both sides, and that leaves me with the quartic root of 6c plus 25 is equal to positive 5. So then I raise both sides to the fourth power to get rid of that quartic root. 5 raised to the fourth power, that's 5 times 5 times 5 times 5. 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625. So we get 6c plus 25 is equal to 625. Subtracting 25 on both sides, we get 6c is equal to 600. And then finally, dividing by 6 on both sides, we get c is equal to 100. If you have any questions on anything that we've done today, then please let me know. Again, I'm open to any recommendations that you have, and if you have any homework questions or get stuck on anything or have general recommendations at all, you can feel free to friend and follow me on my Facebook, Twitter, and Instagram accounts. Those are linked in the description below. Also, I am doing SAT problems of the day, roughly per day, but I'm doing all different problems on all of my social media accounts. So you can just get random practice drills, and I'm not repeating values. The only thing that I might do is sometimes Twitter, if I need to answer the question in a picture, and of course Twitter I can't put a picture up, I might put a link up to like my Facebook or Instagram where the picture is. But other than that, there'll be original problems available on all of my media feeds. And if you found this video helpful, please like the stream and subscribe to my channel. I appreciate you guys very much. And if all else is okay, if there's no questions, Dr. Tot, do you want to say goodbye to everybody? Come on, you want a cookie? You got to earn your cookie and say goodbye. Come on. Come on. Come on, Dr. Tot. You give him paw. You say bye. You guys say bye to everybody. Yeah. All right. Thank you guys very much for signing in. I'll talk to you all soon.